In the second half of 4.6, we're going to focus on really writing the equations of parallel and perpendicular lines. Okay? So, there's a couple different ways that we can write the equations of lines. One way is to use slope-intercept form, and another way is to use point-slope form. And I'm going to go over both of these methods with you to write the equations of lines that are parallel and or perpendicular. So remember from the first part, parallel lines have exactly the same slope, and perpendicular lines have opposite reciprocal slope. So for example, if one slope was 3/2, a parallel slope would be 3/2. For perpendicular lines, if one slope was 3/2, a perpendicular slope would be negative 2/3. Okay, we learned that in the first segment of this coordinate geometry lesson. Alright, so the first method I'm going to go over is how to use slope-intercept form to write the equation of a line. If I wanted to write the equation of a line that is parallel to the line y equals 2x plus 3, I can see in this line that the slope is 2. So if I just want to write the equation of a line, it can be any line in the whole wide world, all we have to do is make sure that the slope is 2. So y equals 2x plus 4 would be parallel. Y equals 2x minus 7 would be parallel. I'm just making up these intercepts. The slopes just have to be the same. We can have y equals 2x plus 1027. Okay? As long as the slopes are the same, the lines is parallel. The lines are parallel. But what if I wanted you to write the equation of the line that's parallel to y equals 2x plus 3, but it also had to go through the point 1, 1. Now visually, we could kind of describe this with a graph. We could say, alright, I know it's got to go through the point 1, 1. I know it has to have a slope of 2, so that's up 2 and over 1, or it could be down 2 and back 1. So we could draw a nice picture of it. Once we do that, we can kind of say, oh, the intercept is negative 1. And we could write that in slope-intercept form. But I'm going to show you how to do it algebraically in case you can't tell just by looking at the graph what the equation of the line is. So we're going to start with the fact that my equation has to have the form y equals mx plus b. In order for it to be parallel to this line, I know that m must equal 2. I also know that when x is equal to 1, y must also be equal to 1 because it goes through that point. What I don't yet know is the value of the intercept. I don't yet know b. So what we're going to do is we're going to plug in m for m. We're going to plug in 1 for x, and we're going to plug in 1 for y. You can see that leaves us just one thing to solve for, which is b. So plugging in 1 for y, and plugging in 2 for the slope, and 1 for x, allows us to solve for b. Let's finish and solve this equation. 2 times 1 is 2, and so 1 is equal to 2 plus b. We would subtract 2 from both sides. 1 minus 2 is negative 1. And so negative 1 is equal to b, our intercept. Once we know b, we remember that our slope was 2. So in slope-intercept form, the equation of the line that's parallel to y equals 2x plus 3, and the line that contains the point 1, 1, is the line y equals 2x minus 1. And we can see that looks exactly like what we just graphed right here. Okay? So let's do another example using the same technique. Let's write the equation of the line that goes through the point negative 3, 1 and is parallel to the line y equals negative 1/3 x plus 1. So since it's parallel, I know I want my slope to be negative 1/3. I know that when x is -3, I want y to be -1, but what I don't know is the y-intercept. So let's start with slope-intercept form, and then let's plug in all of the pieces we know. We know the slope, we know a value for x, and we know a value for y. When y is -1, my slope is -1/3. My value for x is -3, and I'm solving for b. And look, I made it really nice for you. My fractions work out very nicely. So let's finish this. -1/3 times -3/1 is a negative times negative, so that's positive, and it's +1. Whoops, not plus or not equals, that should be a plus b. +1 plus b. So we'll subtract 1 from both sides, and we get b is equal to -2. So that's my intercept. And remember, we already knew the slope, so the equation of the line that I'm looking for would be -1/3 x minus 2. And again, it's probably a good idea to plot both of the lines. So the first one was -1/3 x plus 1. So it has an intercept of +1 and a slope of -1/3. Kind of looks like that. And the second one, you can see, has an intercept of -2. And it also has a slope of -1/3. So up 3, or up 1 and back 3. And you can see that it is going through that point -3, 1 that we wanted it to in the condition of this problem. Okay, so now let's talk about point slope form. This is another way to write the equation of a line, and it actually saves you a step in the process. This is an equation that you, again, don't have to memorize. It's available to you on your Ames reference sheet, but you do need to know how to use it. So point slope form is given to us by this equation, y minus y1 equals m times x minus x1. So this is an equation when you have a known slope, that is m, and that line contains the point x1, y1. So for example, if I wanted to write the equation of a line that's parallel to the line y equals 2x plus 3 and contains the point contains the point 1, 1, I can use point slope form to do that. This point here is representing x1 and y1. So it's the x coordinate of the first point and the y coordinate of the first point. And we know that 2 is the slope that I want because it's going to be parallel to the line y equals 2x plus 3. So m is equal to 2, x1 is equal to 1, and y1 is equal to 1. And I'm going to plug these things exactly into this equation right here. So let's just bring that equation right down, and we'll plug those things in. Now the y stays y. I'm subtracting y1, which was 1, and that's going to be equal to my slope, which was 2, times x, which stays x. We have to have an x and a y in our final equation, minus x1, which was also 1. Okay? So that's how we set up the equation. And then what we want to do is manipulate it a little bit to get y by itself. So the first thing I would do is distribute that 2. So we'd have y minus 1 equals 2x minus 2. And then to get y alone, I'd add 1 to both sides, and we'd get y equals 2x minus 1. And we actually already did this problem in that first example, so you can check and verify that we got the same exact equation as we did the last time. So I want to do one more example, but this time we'll work with a line and finding an equation that's perpendicular. So let's write the equation of the line that goes through the point 3, 2 and is perpendicular to the line y equals 3 halves x plus 2. So the slope that I'm going to want is going to be negative 2/3. I want it to contain the point 3, 2. So that's going to be x1 and that's going to be y1. So again, let's start with our point slope form and plug in the values that we see here. Y stays y, but I'm subtracting from that y1, which is 2 from right here, and that's going to equal my slope, which is negative 2/3 times x, which stays x, minus x1, which was 3. Okay, great. Now what we want to do is distribute and then get y by itself. Okay, so when we distribute here, pay really close attention to your fraction, but I made it again so it works out pretty nicely. So this is going to stay y minus 2 on the left. Negative 2/3 times x is negative 2/3 x, and then a negative times a negative is a positive. And what we have is 2/3 times 3/1. So you can either write that out or do the step in your head. Either way, it's fine. So we'll have y minus 2 equals negative 2/3 x, and then 2/3 times 3/1, my 3's cancel. That's going to be plus 2. Now we're going to add 2 to both sides, and we get my final answer of y equals negative 2/3 x plus 4. Now, you absolutely should graph these to make sure that they go through the points that they're supposed to go through and that they look the way that they're supposed to look. In other words, that they look perpendicular to one another. So let's see if we can do a really quick graph here. Maybe this one. It's kind of big. Whoopsies. Let's see. Let me make this graph a little bit smaller here. And then we can graph these two equations. So the first one was 3/2 x plus 2. So that had a y-intercept of 2 and a slope of 3/2. So that's up 3/2 like this, or down 3 and back 2 like that. We get a line, draw a nice straight line through it. My other equation, negative 2/3 x plus 4, has that y-intercept of 4 and a slope of down 2/3, down 2/3, or up 2 and back 3. Oops, that's back 4. Let's fix that. Up 2 and back 3. There we go. I'm just going to do one more point so I can get a really good line here. And then connect them in a nice straight line. Now, two things need to happen here. The first thing is my lines need to be perpendicular, but I'm cool with that. It looks like they intersect at a 90-degree angle. The second thing is that my second equation needs to contain the point 3, 2. So over 3, up 2, and we can see that it does go through that point. So I'm pretty confident that y equals negative 2/3 x plus 4 is the correct equation of that line. Alright, so I want you to work on your summary again, and you need to talk about how to write an equation that's either parallel or perpendicular to a line, not a ling, hello, a line, and it has to go through a specific point. What would be the method that you would choose to do that, and how would you describe that method? That's what needs to go in your summary. Okay?